What's up guys? My name is Alex and in today's video we're going to talk about two things. We're going to take a look at how you can go from an Arduino to a breadboard, and then once you're on a breadboard, how you can program the Arduino or the ATmega chip that's right here using something like a standalone USB to serial adapter like I have it over here. I plan on doing a few Arduino projects on the channel, so I figured let's start with the basics. Let's take a look at how you can move an Arduino onto a breadboard, and then we can build some cool projects with it. So without further ado, let's take a look at how it's done. So here we have an Arduino Uno by itself, and the first thing I want you to notice is that it's running the blinking example. As you can see, the LED that's tied to pin 13 over here is actually blinking. If you haven't seen this example before, it's one of the most basic things in the Arduino IDE, and you can find it under File, Examples, Basics, Blink, and all this does is exactly what you see here. And it just blinks that LED that's tied to pin 13. So I just want you to know that that program is already preloaded in the ATmega328P chip. That's basically the heart or the brains of the Arduino, if you will. Alright, so what I'm going to do first, I'm going to disconnect the power. So here we have the Arduino. And you have a couple of options in order to move the ATmega chip onto a breadboard. The first thing you can do is you can pop the existing chip off of the Arduino Uno and then pop it onto a breadboard. The second thing would be to actually buy separate ATmega chips, because you can buy these separately outside of the Arduino platform, and you can just use those and put those on a breadboard or a PCB or whatever you like. Something to note here though, if you're buying these chips separately, the ATmega328P chips, is make sure that they have the Arduino bootloader already on them. This will allow you to actually program Arduino programs and put them on the chip itself. If they don't have the Arduino bootloader, you can manually burn the bootloader onto the chip, but that's kind of a separate step, and I'm going to show that in the next video, not in this one. So just make sure when you're buying them to look if they have the bootloader already preloaded, and if they don't, you should just expect that you'll need to do some more setup in order to use them on a breadboard. Now, if you're going to buy these chips separately and you're going to use them on a breadboard, you can just use the ATmega chip itself. However, if you're prototyping, you're done prototyping, and you want to put your project onto a PCB or something, I recommend getting these. And these will often come bundled with the ATmega chips themselves. These are like sockets, and you can actually solder. You see, you can solder these legs onto a PCB, and then you can actually take in and out chips out of this socket without actually soldering it in place. So this allows you to, even after you're done and you've put everything on a PCB, it allows you to actually remove, replace chips, and maybe have several different programs on different chips and take them in and out and stuff like that. So I would recommend that you guys get these and solder these onto the PCB instead of soldering the chip directly. Okay, anyway, so if you're actually going to use the chip that came with your Arduino, like the one I have over here, the Arduino Uno, popping this chip out of the Arduino is really easy. All you have to do is to have a screwdriver and then just kind of put it in from the sides and just pull up a little bit on it. And I recommend doing that on both sides because that makes sure that the legs of the chip come out evenly and you're not gonna bend them or anything. So you just pull up a little bit and then you can take out the chip. As I said, the legs can bend really easily, so just be careful when you're doing it. One thing to note once you're at this point is this chip obviously has an orientation, so it's not the same thing if you place this chip into the Arduino this way or this way. Depending on how it's rotated, obviously the pins are different. In order to determine the correct orientation, what you have to look for is, if you look at the chip, and I don't know if this will show up on camera real well, but I'll tilt the chip a little bit. You see that little notch at that end right here? So that notch corresponds to a notch on the socket itself. So let me just grab this socket, and it's the same socket that you see over here. And I don't know if you can tell, but right over there is the same notch. So that's how you know how to line them up. So if I look at the Arduino, that notch is on this side right here. And again, I don't know if it will show up on camera, but if you have it in person in front of you, you'll see what I'm talking about. So that notch is over here, meaning when I'm placing this chip back, I have to make sure that the notch on the chip corresponds to the notch over here. So I will face the notch this way towards this notch and then push it into place. Okay, the point of this video is to take it out and put it on the breadboard, so I'm not gonna pop it back in. But I just wanted to tell you that if you're taking it out of the Arduino Uno, that's basically the way to do it. Now you have a standalone ATmega328P chip, in this case on the Arduino Uno, and now we can work with it. Alright, so here we have a completely empty breadboard, and the first thing I'm going to do is I'm going to share the power between the lines over here and there, just so it makes things easier down the line. So I'm just going to connect the positive to positive and the negative to the negative here, so that I don't have to provide power separately to both lines. Alright, there we go. The next thing obviously is putting the chip on the breadboard itself. Remember earlier I said if you're putting this on a PCB, you better solder a socket onto it, and then you can plug this into a socket. If you're working with a breadboard, the chip can go on the breadboard directly. It's the proper spacing for the legs on the breadboard. So keep in mind, one thing to keep in mind is that notch I was talking about earlier, it's right here, because when you're looking at the chip itself, if you face the chip so that notch faces upwards, you can see it's right there, then pin 1 is going to be the pin on the top left side of the chip right here, and then the numbering goes pin 2, pin 3, pin 4, pin 5 downwards, and then you get to pin 14 over here, and then you continue pin 15, 16, 17, 18 to 28, I believe. So I believe that it starts with pin 1 in the top left, goes downwards, and then rotates around the chip and then goes upwards. And this is important because once we start connecting components, you have to kind of keep an eye out on which pin is which number so that you know what to connect and where. In editing, I'm probably gonna show you the pinout of the ATmega chip on screen so that you guys can follow along. Right now I'm just going to explain where everything goes, and hopefully between both of those you'll kind of have an idea of where everything goes. Okay, so the first thing, let's put the chip onto the breadboard, and just be careful that all the feet of the chip line up and they go exactly where they need to, so you don't bend anything. All right, there we go. Now let's start with pin 1. And well, not all the pins on the chip, you're not going to need all those pins immediately. Some of them you might need, some of them you might need later. So I'm just going to show you the bare minimum of what you need to connect to actually get this up and running. And then obviously, depending on the project you're working on, you may need to change things up a little bit or add more things to different pins and stuff like that. So the pin 1, as I said, if you're facing the notch sort of upwards, it's going to be the one on the top left. So that's this pin right here. Pin 1 is the reset pin. And if you look at the Arduino, there's a reset button right here. That little tactile button right over there. So that's going to be the reset button. And if you want to take advantage of that functionality to be able to reset your application on the breadboard, you're actually going to have to, you're going to want to connect such a button to your breadboard as well. So you have a couple of options. Option 1, the reset pin is active low. What that means is that as long as it's high, as long as it's tied to positive 5 volts in this case, it's actually going to run just fine. And then as soon as you bring it low to ground, you're going to reset the Arduino, and then their application is going to start from start. So you can actually take the first pin and you can tie it high immediately. So that would be something like this, right? So if I were to do this, this is, as soon as it gets power, it's going to start running my application, and the only way to reset it would be for me to manually unplug this and tie it to ground so that I can reset it and then tie it back, or maybe unplug the power and plug it back in. So in my case, I want to be a bit better than that, so I'm actually going to add a small push button so that I can reset it as needed. In order to do that, first thing we want to add the push button itself. So I'm just gonna use one of these tactile buttons. Trying to orient it for the camera. There we go. I'm gonna use one of those. And the way I'm hooking this up is that one side of the button goes to pin 1 over there, and the other one is on this side, a couple of pins over. So one of them is obviously connected to the chip, the other one isn't. Now I'm gonna take a resistor, and in this case I'm using a 10 kilo ohm resistor, and I'm gonna pull that pin high. So essentially I'm gonna connect it between on the same side where the tactile switch is and positive voltage. There we go. So by default, the way this is set up right now, through the resistor, the ATmega chip is actually connected to positive voltage, meaning it's going to be pulled up high without actually pressing the switch or anything like that, which means the Arduino will be set up to run, or I shouldn't say the Arduino at this point, I should say the ATmega chip will be just set up to run normally. So as we said earlier, as long as this pin 1 is pulled up high, the ATmega chip runs normally. As soon as you pull it low, that's where you reset the chip. So we can accomplish that by taking the other side of the push button over here, and we can tie that to ground. So essentially what happens is that this pin is going to be pulled up high as long as you're not pushing this button, and then as soon as you push this button, current is going to go through the button and then being pulled up low to ground, which means you're going to reset the chip. And then as soon as you release the button, you're again going to go and pull it up high through the resistor, and the normal operation is going to resume. So that's how you add a reset functionality that's basically identical to the reset functionality on the Arduino Uno over here. And then if you don't want this, if you're gonna make this minimalistic and put it on a PCB, you don't need any of this setup. You can literally just tie it high, and it's always gonna run as long as there's power in it, and you can just interrupt the power to reset it or something like that. Okay, the next thing we're gonna do is we're actually gonna provide power to the ATmega chip, and positive power is on pin 7. So if we just count 7 from here, it's gonna be right here. That's gonna be plus 5 volts. And then pin 8 is the ground pin, so right next to it. Okay, once we've provided power and ground, now we actually have to provide the frequency for the Arduino. And in order to do that, we actually have to provide a 16 megahertz. I don't know if you can read that. This is a 16 megahertz crystal oscillator. And this goes between pins 9 and 10. So remember, this was 7 and 8, so this goes in the pins right next to that. There's actually a way to run the Arduino without any external components like this oscillator over here, and I'm gonna tackle that in the next video. So if you're interested in that, I'm gonna put a link in the description below, or maybe a card on the screen or something, and you can check that out. For now, I'm actually gonna add this crystal oscillator, and again, if you look at the Arduino Uno itself, right here is that same 16 megahertz crystal oscillator. So that goes between pins 9 and 10, as we said. Okay, and then to complete the oscillator circuit, we also have to add two, I believe these are 22 picofarad capacitors, and they will go from pins 9 and 10, and then both of them go to ground. All right, so 22 picofarads from pin 9 and 10 to ground. Those are basically on the two pins where the oscillator is connected to. All right, we're almost there. The next thing we actually have to take a look is the ATmega328P chip comes with an analog to digital or ADC converter. Now, you may or may not want to use that depending on the project. In this example, I'm not going to use it, but I'm going to explain how you can add that and set that up in case you want to use the analog to digital converter. So there's three pins associated with the ADC. And now the thing to note is that the ADC needs separate power from the power that we provided over here to the actual ATmega. So the power is on pin 20 and 22. 20 is the positive pin and 22 is ground. So as we said before, the counting starts from the notch from the left side, 1, 2, 3, 4 going downwards, and then this is pin 14, and then 15, 16, 17 going upwards. So let's figure out where pins 20, 21, and 22 are first. Pin 22 is the ground pin, so I'm going to start with that first. Okay, just double checking. So pin 22 is the ground pin. We connect that to ground. Now, as I said, pin 20 is the positive voltage for the ADC. Now, if you're going to use the ADC converter, you need to provide the positive voltage there through a low pass filter. This is kind of out of scope or this particular video, but you can Google that separately if you want to. And that's because you want to keep any noise down so that you can get like proper analog to digital conversion. In this case, because I don't really need it, I'm not gonna take advantage of it, I'm just gonna tie pin 20 to high. I'm just gonna tie it to 5 volts. As I said, if you want to use it, you have to provide the positive voltage on pin 20 through a low pass filter. Okay, there we go. Now, pin 21 is the reference voltage for the ADC. Now, what does that mean? Well, if you think about it, let's say that you're providing 5 volts on the positive ADC line, and then this one is obviously tied to ground. Now, the analog voltage can be anywhere between 0 volts and 5 volts, right? Anywhere in that range. But in order to determine what is considered digitally high and what's considered digitally low, you have to have some reference voltage. So let's say that the reference voltage is 2.5 volts. If you provide 2.5 volts on pin 21, so in between these two pins that we've used over here, that's going to mean that everything higher than 2.5 volts will be converted to digital high or a 1. And then everything lower than 2.5 volts will be a digital low or a 0. Now again, providing that voltage is out of scope of this video. For my purposes, what I'm going to do is I'm actually going to tie the reference voltage high as well. I'm just going to tie that high. So essentially it's pin 20 is the reference, pin 20 is the positive voltage 5 volts. The reference voltage is also 5 volts, and then just ground goes to ground. Again, if you're actually setting this up to use the ADC, make sure that this pin 20, goes through a low pass filter to make sure there's no noise and frequencies you don't want. And then the reference voltage needs to go to whatever your reference is for determining what's high, what's low. Maybe in your application, you want to have, let's say, everything lower than 4 volts be a 0. And everything from 4 to 5 be a high. In that case, you will actually provide a reference voltage of 4 volts on pin 21. Again, that depends on your current implementation. For our purposes right now, you can just tie them this way, and that's going to work just fine. And that's pretty much it. This is basically functionally the same thing as you have here. The chip is set up in a way where it will actually run the application that you stored on it as long as you provided power. Now, obviously, the problem right now is that there's nothing telling us whether the chip is going to run or not, right? We don't have any LEDs and indicators. We don't have any servo motors or stepper motors or anything. The ATmega chip basically doesn't control anything, so it would be very difficult to say whether or not this is actually running properly. So in order to do that, let's add an LED. And what I'm gonna do actually is I'm gonna set it up in the same way like what we have it here. If you remember, the chip itself was programmed to run that blink LED application, which blinks the LED that's tied to pin 13. Now, something important to note is that even though the Arduino labels that as pin 13 over here, that's not actually on pin 13 of the ATmega chip. The ATmega chip has its own pinout, and the Arduino just kind of shuffles those pinouts around. They still exist over here. You just have to kind of look at the pinout, and I'll put that on screen. You have to look at the pinout to determine which pin goes where. So in this case, the pin 13 on the Arduino equals pin 19 on the ATmega chip. So let's connect that. So what I have here is a 200 ohm resistor, and we're going to connect that to pin 19, as we said. Pin 20 is the positive voltage here, so this is pin 19. There we go, with a 200 ohm resistor, and then I'm going to connect just a green LED to the resistor. On the positive side, the longer lead goes to the resistor, and then the negative one will go to ground. There we go. And then basically at this point, all that's left is for us to provide power to the Arduino so that we can see if it works. Now, I don't really actually have a power supply here, so what I'm going to do is I'm actually going to give power to the Arduino itself. And of course, at this point, I don't have a chip over here, so the LED is not blinking, the Arduino is not actually running properly, if you will, and I will just use it as sort of a power supply in this instance. So I'm going to take these two leads and connect them to the output from the Arduino, 5 volts and ground. If you look at the Arduino right here, you can actually see labels for 5 volts and ground right over there where I connected these two cables. And then 5 volts is going to go in here, and ground is going to go in here. And I don't know if you can see that on camera, but the LED is blinking. So basically what we've done right now is we're using the Arduino to provide power at this point. Don't get confused, you don't need this portion at all, right? You can provide this power in any way. You can use a battery, you can use a power supply. USB power supplies are really good for this. You can just kind of chop off the ends of the plug if you have a spare USB power supply for charging phones or something, and then just take out two leads, plus 5 volts and ground, and you can use that as the power supply. The important thing to note is that the LED is blinking, meaning our application is running perfectly fine. And what I'm actually going to do here is I'm going to hold down the reset button. You see how it's not blinking anymore? That's because the reset switch is now tied to ground because I'm still holding it. As soon as I release it though, see that the several fast blinks is basically the bootloader starting up and the application restarting, and then it starts blinking normal. So we know that our reset functionality also works as expected. And that's basically the first portion of what I wanted to show you today, which is how you can actually take the ATmega chip off of an Arduino, put it on a breadboard so you can use it as a standalone sort of project. And you can even solder this onto a PCB and add stuff to it, and you don't need the Arduino anymore, which is really convenient because the Arduino is great for prototyping, but as soon as you want to actually create a product out of it and maybe put it on a printed board and stuff, you kind of want to get rid of this part, right, so that you don't waste space. Now, let's go on and take a look at how you can actually program the chip once you're in this configuration and you actually have a standalone breadboard setup like this. Okay, so you have a couple of options at this point. What I used to do back in the day is you can actually take out the chip from your breadboard configuration and put it back in the Arduino. Use this to program it as normal through the Arduino IDE with everything that you used to do on the Arduino itself. And then once you're done, once you've reprogrammed the chip, you can put it back in. Obviously, you have to just keep an eye out for, the orientation of the chip and the pinout. Like when you're taking out, for example, the notches over here. So you have to make sure to orient that notch with the notch over here on the Arduino. Same orientation. You program it, you pop it back off, you put it back on the breadboard. Again, keep an eye out for where the notch is. Keep an eye out that pin 1, it matches up with this leg of the tactile push button over here. just so that the pin lineup is proper and everything lines up properly. When you do that, you're essentially gonna use the Arduino as the programmer, which is fine. It works just fine. The annoying part about that is that you actually have to just keep taking the chip on and off, which may get tedious, especially if you're actually putting this in a complicated project with a lot of stuff going on. Maybe some leads are running on top of it, like there's a whole mess of wires or something like that. It's gonna make it a pain to actually take this out every time you want to change something or tweak something. And that's where a standalone USB to serial adapter or converter comes into play, and I'm going to show you now how you can actually connect that. So in this case, what I have here is an FTD1232. These are fairly popular, or variations of them, and what this is essentially a USB to serial converter. On this end, this is connected to my computer through a USB port, and then over here at the bottom you have a pinout. I believe there are labels. I don't know if you can see them on camera, but there are labels right there in between. Yeah, right there, and it actually tells you what each pin is going to do. And I'm going to explain how these are connected to the ATmega on the breadboard. The version of this converter you may find may differ, but generally the pinout will be similar, and I'm going to tell you what each pin that we need does, so that even if you have something different, it's going to be fairly similar and fairly close to what I'm going to explain, so you'll probably be able to get it up and running. I should note that the Arduino itself has one of these sort of built in, right? Because when you connect the USB port here to your computer, you're programming this chip through a kind of a similar deal. You're programming it through a USB to serial converter, and you have a serial monitor. If you've done any Arduino projects, you're familiar with that. So that's kind of the advantage of having this whole thing in one single package. You don't have to worry about anything else. When you start putting it up on a breadboard like this, you actually have to do some more work to get that up and running. Okay, so the three important pins that you have to keep in mind in order to set this up are RX, TX, and DTR. And they might be labeled slightly differently in your case, but generally that's going to be, if you look at the documentation with your device, you'll probably be able to find out the TX pin is the transmit pin, the RX pin is the receive pin, and then the DTR pin is data terminal ready, I believe it stands for. And that's basically sort of like a reset, like when you're about to start programming, that pin will sync up with your device so that they're both kind of on the same page, and then data can flow to and from. And what essentially needs to happen in order for us to set this up is the TX pin on this USB to serial converter has to go to the RX pin on the ATmega, and the RX pin from the converter needs to go to the TX pin of the ATmega. It's essentially just a TX, RX, RX, TX relationship. And then the DTR pin has to go to the reset switch, but there's a little bit of potential problem here, and I'll explain that when we get there. So let me just connect this first and we'll go from there. So I'm just going to connect this onto the breadboard right here. And there we go. Obviously, nothing on this side is connected yet, so we'll deal with that in a sec. So let's just start with connecting the RX and TX pins between the between the USB to serial converter and the ATmega chip. Okay, so pin 2 on the ATmega is the RX pin, and pin 3 is the TX pin. So let's go pin 2. So RX needs to go to TX on our device, and TX is pin 3 over here. And then pin 3 on the ATmega needs to go to, so pin 3 on the ATmega is the TX, it needs to go to the RX over here. Pin 2. There we go. And then you just need to connect the DTR pin to the reset pin. Now, I had some problems with this and I did a bunch of research online, so I'm gonna show you what I did to overcome the problems I had. I don't know that you're necessarily gonna be in the same situation as I was, but I'm gonna tell you what I did anyway, and then hopefully it helps you out. So when I was connecting the DTR pin directly to the reset pin, so I believe this is pin 1 here as well on this serial to USB to serial converter. So when I was connecting pin 1 to pin 1 here, I was getting a lot of desync messages when I tried to actually upload something from the Arduino IDE, and that's because they were not syncing up. The data terminal already was not properly working. So in order to fight that, I actually had to add, let me check this. It's a 10 microfarad electrolytic capacitor that I have over here. So I actually had to add that in between the connection that goes between these two devices or chips. Now the positive side, the longer lead, oh sorry, that's not in camera. The positive side, the longer lead actually goes towards the USB to serial converter, and the shorter lead, the negative side, goes towards the reset pin. So I'm just gonna connect this in the same pin where the resistor is connected. There we go. And as I said, that's a 10 microfarad electrolytic capacitor. And now we can actually connect pin 1 from here to that capacitor that we just added. So initially I had this cable go from DTR directly to the reset. What I'm doing now is I'm going from this to that capacitor and then through the capacitor to the reset pin, which is, it's on the same pin where the resistor is connected here. And I hope that makes sense. So nothing too crazy, 3 pins. RX goes to TX, TX goes to RX, and DTR goes to reset. You may or may not need this capacitor depending on the device you have. I'm just giving you the option here. Now all that's left to do is for us to actually reconnect the power, and we can see if everything works. The cool thing here is that because this is already connected to USB, it actually provides pinouts for +5 volts and ground. So I can use these pinouts to actually provide power to the breadboard now. I don't have to do that whole thing with the Arduino on the side. Alright, so looks like the power pin is labeled VCC on my device, and that's gonna go here. And then the ground pin is the last pin that's gonna go here. Okay, now if I connect this to +5 and this to ground, the LED starts blinking again, meaning we got power, so everything is running. So now all that's left is to check whether or not this whole setup actually works, and we can actually program this chip using our Arduino IDE. I know this is not like really pretty to look at. You can actually shorten these leads with something more permanent on the breadboard, and then you can just unplug this serial USB to serial converter if you want to program. When you don't need it, you can just unplug it and provide power from something else. The important thing to note is the setup of those 3 pins and potentially the capacitor, which you may or may not need. Let's go back to the Arduino IDE and see if this thing works. Okay, here we are. This is the blink example. As I said, that's you can find that in File, Examples, Basics, Blink. That just blinks the LED. And then if I go here into Tools, the board is Arduino Uno, which is fine. And if I go into Port, you'll see COM4. Now, you have to be careful here. If I connect, and I'm actually going to do it just so you guys see what happens. I'm going to connect this Arduino to my PC as well. There we go. And if you look here, I have COM3, Arduino Uno, and then COM4. Now, COM3 is the original serial port. That's the built-in converter in the Arduino itself. As we said, there's one that's built in here. So the built-in one is found on COM3 for me, and then the COM4 port is used by the standalone USB to serial converter. You just have to be careful that if you have multiple serial ports, you have to choose the correct one, obviously, that does the job. So I'm just gonna leave COM4 selected. So what I'm gonna do now is I'm actually gonna program this empty sketch. So this is just a new empty sketch, doesn't do anything, and I'm gonna program that onto our chip that's already up and running. And if I switch back here so you can see what's happening now, as you can see, this LED is no longer blinking. And that's because we've programmed what's essentially an empty program that just loops and does nothing. We've programmed that onto the ATmega chip, meaning the LED is off. Now I'm gonna go back and I'm actually gonna open up the blinking example again. And I'm gonna upload that, and I'm gonna switch the view that you can see. There we go. Once the upload finishes, the LED starts blinking again. So that means that our setup with this serial to, sorry, I keep messing that up, USB to serial converter is proper, and we can actually upload applications to our ATmega chip, and the whole setup is fine. And that's pretty much it, guys. So that's how you can turn, you can grab an Arduino, we can grab an ATmega chip off of an Arduino, put it on a breadboard, and also that's how you can actually program the ATmega chip once it's on a breadboard or a printed board, whatever, what have you. As I said before, if you want to look at how you can bootload an Arduino bootloader onto how you can burn an Arduino bootloader onto your ATmega chip if you've purchased some new ones from the store and they don't have the bootloader already on it. I will be showing you that in the next video. And also in the next video, we're going to take a look at how you can run all of this without all of these external components that we added over here. So I'm going to show you a very minimalistic way of running the ATmega chip, no external components, which is great for projects which are maybe in a super tight space and stuff like that. So stay tuned for that one. If you want to make sure you don't miss that one, be sure to subscribe to the channel. If you like this video, like it. If you don't, dislike it so that I know what works, what doesn't. And until next time, peace.